Now see the part 2 of ionic equilibrium. Part 2 of ionic equilibrium. So look at the question number 6. Aqueous solution of which of the following compound is the best conductor of electric current? So see, a strong electrolyte. For good conductor, strong electrolyte with furnaces ions completely in the solution will be the best conductor of electricity. So first write the statement only, a strong electrolyte. So this will be the best conductor which furnaces ions completely in its aqueous solution will be the best conductor, will be the best conductor of electricity in aqueous solution. Right, so see the who is the strong electrolyte now, like HCl. So when it dissociates with water, it forms H plus and Cl minus, right? So suppose I am taking 0.1 molarity. So initially it is 0. So after the dissociation, it will become 0.1 minus 0.1, right? So it will become 0 and this will increase the concentration of H plus and Cl minus, right? So this is at the equilibrium. Right, now see for the next point, second point. Fructose and ammonia are not an electrolyte, while so it is talking about fructose, right? So fructose general formula is C6H12O6 and ammonia NH3 ammonia. Right, so this will dissociate partially, right, as they are weak electrolytes, not electrolyte, while the acetic acid is weak electrolyte. So let's see the weak acetic acid. So its formula is CH3COH. So it will dissociate into CH3CO minus plus H plus, right? So this will dissociate partially. Now see the next point in that question only. So HCl is there. So it is the strong electrolyte. It is a strong electrolyte. So when it dissociate into H plus Cl minus, we completely dissociate into H plus and Cl minus, right? In the previous example we have given like HCl, when we have taken 1 molarity, right? So when it dissociate into H plus and Cl minus, so this is the initial condition, right? So it is initially concentration of H plus and Cl minus is 0 at equilibrium, right? So its concentration will be 1 minus 1, right? So it will become 0 and H plus and Cl minus concentration is increased. So HCl with the, so HCl will be the best conductor of electricity. HCl is best conductor of electricity, right? So right up to this point. Now look at the question number 7. So when KMnO4 potassium permanganate can be prepared from, so it is prepared from K2MnO4 as per the reaction. So please write the reaction. So it will be 3MnO4 2 minus, so it is minus, and it is reacting with water, so it forms 2MnO4. Reaction is given, right, plus MnO2 plus 4 OH minus, right? So the reaction can go to completion by removing the OH minus. So after removing this OH minus concentration, this will go to completion, right? So next point. So it is asked in 2013. So let's see the explanation for that. So when KOH is there, so KOH is base, right? Because it is OH there, right? So it is base, that thus it after dissociation gives K plus plus OH minus, right? So thus it can't be removed OH minus ion from the reaction mixture, but it add on the concentration of OH minus. So the acid can be added if the strong acid is added to the reaction mixture in acidic solution, reduced to Mn2 plus, right? So MnO4 minus will be reduced to Mn2 plus. Thus ACl is a strong acid. So ACl will dissociate into H plus plus Cl minus. It is a strong acid. So it completely dissociate. Now see the SO2, which on treatment with water. So when it react with water, it forms H2SO4, which can't be used for the purpose. So can't be used for purpose, right? Thus CO2 will be formed when CO2 react with water. So these gases are like SO2 and CO2 are acidic in medium. So CO2 react with water, it forms H2CO3, right? So it is weak acid. React with OH minus. So it is reacting with OH minus, but can't be much acidic, right? Then MnO4 minus undergo reduction. So it will go the under reduction process. Right. So CO2 can be used for the completion of this reaction. So main answer will be the CO2. Right. So this comes under the option C. So C option will be the correct answer. Now see the question number 8. Dissociation constant for acetic acid and HCN is given as. This is your acetic acid. General formula is CH3COH. Its dissociation constant is given. K is 1.5 10 raised to minus 5. And dissociation constant for hydrogen cyanide. Hydrogen cyanide. So K is given, that is 4.5 10 raised to minus 5. It is minus of 10 given. So equilibrium constant for the reaction, you have to find it. So Cn minus cyanide ion react with acetic acid. It forms HCN plus CH3CO minus. So it is asked in 2009. 2009. Right. So it will dissociate like CH3CO minus plus H plus, right? So K1 value is given, that is 1.5 10 raised to minus 5. In the similar manner, CH3COH, acetic acid, it will consume Cn minus and dissociate into HCN plus CH3CO minus. So equilibrium constant of A by concentration of 2. So it will be 1.5 10 raised to minus 5 divided by 4.55 10 raised to minus of 10. So it will be 3.33 10 raised to 4, approximately equal to 3 into 10 raised to 4. This will be the answer for that. Now see the question number 9. What is the concentration of? So it is talking about concentration of OH minus in the final solution by mixing of 20 ml of 0.05 molarity of HCl, right? It is reacting with 30 ml of 0.1 molarity of barium hydroxide, right? So it is asked in 2009 again. So let's see. So number of equivalent of H plus is equal to 20 into 0.05, right? So it is nothing but concentration into volume. So this is your volume given and this is your concentration, right? So it will be how much? It will be the in milli equivalent. So this will be equal to 1.0 milli equivalent, right? So now see the next point. So next point is number of equivalent of OH minus. Number of equivalent of OH minus. So it will be 2 into 30 into 0.1. So this is calculating for BaOH2 base, for base, and this is for acid. So it will be how much? It is equal to 6 milli equivalent. Thus equivalent of OH minus left after neutralization. So how much equivalent of OH minus is left? Equivalent of OH minus left for neutralization after neutralization. So it will be how much? 6 minus 1 equal to 5 milli equivalent. So total volume now calculate. So this is the third part, this is the fourth part. Total volume. So it will be 20 plus 30. So it will be 50 ml. Right. So OH minus concentration will be how much? 5 milli equivalent by 50. So it will be 5 by 50. So it will be coming out to be 0.1 molarity. So write the whole explanation now. Now see the question number 10. The value of Kp1 and Kp2 for the reaction is given. So when X dissociate, it forms Y plus Z. So equilibrium constant for this reaction is given Kp1. And when A dissociate, it forms 2B. So Kp2 reaction is given. So they are given in the ratio 9:1. So when we are taking this ratio, so it will be 9/1. The degree of dissociation of X and V will be equal. So alpha, degree of dissociation of X and A will be equal. X is equal to A. X alpha into A alpha is same. So total pressure of equilibrium will be. So it is asking about total. So it is total pressure at equilibrium. Right. So total pressure you have to find in the ratio. So it is asked in 2008. So let's see the explanation. So suppose first equation. So when X dissociate into Y plus Z, so initial value is 1. Suppose I am taking. So it is 1 and it is not formed Y and Z initially. So at equilibrium it is formed. So that will be 1 minus alpha. It will be alpha. This will be alpha. So total moles will be how much? Total moles is equal to 1 minus alpha plus alpha plus alpha. So this and this will get cancelled. So total mole will be 1 plus alpha, right? So for concentration of X at equilibrium, so it will be how much? X is 1 minus alpha, right? 1 minus alpha, and total is 1 plus alpha divided by 1 plus alpha. In the similar manner, you can find the concentration of Y. So it is alpha upon total 1 plus alpha. In the similar manner for Z, so Z concentration will be alpha upon 1 plus alpha, right? So write the Kp1 equilibrium constant at pressure P. So take P1 as total pressure at equilibrium, total pressure at equilibrium. So Kp1 is equal to concentration of X into P1 divided by concentration of Y into P1. Similarly, concentration of Z into P1. So write concentration in a square bracket. Now put the value. So X value we know, that is 1 minus alpha upon 1 plus alpha, right? So it will be how much? So this one we have to take reverse, right? Because in the reaction Y plus Z is in the product side and this is in the reactant side. So this should be written in the upper part and this should be in the, so this should be in the numerator and this should be in the denominator part. So value of Y is alpha upon 1 plus alpha. In the similar manner for Z it is also alpha upon 1 plus alpha into P. So it will be P into P, that will be the P square then. And for the X value it is given that 1 minus alpha upon 1 plus alpha into P1. So let's explain it. So after multiplying you will get like as this one. So Kp1 will be looking like this. So it will be alpha by 1 plus alpha whole square into P1 square divided by 1 minus alpha upon 1 plus alpha, right? So this is whole square, this is 1. So this and this will get cancelled, 1 plus alpha. So remaining will be alpha square, P1 square. Here P1 is also there. And this will be the remaining 1 plus alpha into 1 minus alpha P1. So cancel the 1 P1, right? So as we know the formula like A plus B into A minus B. So it is nothing but it is A square minus B square. So it is A plus B, A minus B. So it will be alpha square P1 divided by 1 minus alpha square. So this identity we have used here in this, right? Now see for the second. So this is your Kp1, right? Now see for the next equation when A dissociate into 2B. So it will be nothing but initial value is 1. So it is 0. So it is initial. So at equilibrium it will be 1 minus alpha and this will be 2 alpha at equilibrium. So total moles, calculate total number of moles is equal to 1 minus alpha plus 2 alpha. So we have to add these two values A and B. So it will be 1 plus alpha, right? So in the similar manner find the concentration of A and B here. So concentration of A will be 1 minus alpha divided by total. So it will be 1 plus alpha, right? And for the B, what will be the concentration? It will be 2 alpha divided by 1 plus alpha. It is 2. So now put the value now. So for the Kp2, we take the concentration of B, right? So it will be concentration of B square into P2 square divided by concentration of A into concentration of P2.